Hello all, I Rahul Jadhav, Assistant Professor, Department of E&TC, AISSMS IOIT. Welcome you all in this video lecture on inline functions in C++. One of the objectives of using function in the program is to save memory, which become appreciable when function is likely to be called many times. So why we use functions in our program is to save memory, because if the same task is to be repeated again and again, so instead of writing down that code repeatedly, what we can do, we can call a function. So you can use this link to know more about functions and how the transfer of control flow is taking place when functions are called. So you can use this video. The link is also there in the description, or you can use this link and you can learn more about functions and how the transfer of control flow is there when different functions call are made. So however, every time when function is called, it takes some extra time in execution of the series of instructions, such as jumping to the functions, then saving the registers of your CPU, then pushing the arguments on the stack, and also storing the return address on the stack. So whenever a function is called, these values are stored or saved. So that may require some additional time. So let us see that by one example. So in this function, we have declared three variables and then we are calling a swap function, and this is the end of a main function. So in this main function, we are calling a function called swap. So in this swap function, it will be defined at different memory locations. Let us say the address is starting with 500, then 501, 2, 3, and after that it will be the end of the swap function. So whenever such kind of program is executed, here we are using a normal function call. So when such programs are executed, when the compiler will start execution, it will start with the first line in the main, that is at location 100, or let us say at address 100, and after that it will execute at address 101. So at 101 it has encountered a function call. So what will happen at this line? It should now execute the function which we have written, that is swap, which is at address 500. But before it directly jump to this location 500, it has to do something, or it has to store some values. So what values it has to store? It will store the arguments of a function, like a and b in this case will be stored on the stack. Also it will store the CPU register, that is the current value in the CPU registers will be stored on the stack, and it will also store the return address. So why this return address is required? So whenever function execution is over, your compiler should know at which address I should return. Okay, so for that, return address is also stored on the stack. Once everything is done, after that this function call is executed. So that means your compiler will now jump to the location 500 and it will start executing the statements which are there inside the function. So once you reach to the end of your function, then it should return back to the main function, that means where it has called the swap. That means it should return back at address 102. So once it reaches to the end of swap function, it will pop again all the elements from the stack which are stored, and it will jump back to the line number 102 or address 102. That means return address. From where compiler will get this return address? It will get it from the stack where it is stored while calling the function. Okay, so all these operations will take place when you call a function in your program. So it reduces the memory, using function reduces the memory, but it will increase this overhead of storing these values on stack and again popping it back when it is returning from the function. So some extra time will be required in this process when a function call is made. Okay, so when a functions are small, So if you have very small functions, even though this all steps has to be done, that means return address has to be stored, arguments has to be stored, CPU registers has to be stored. So in some cases what will happen, the time required for execution of a function is very less as compared to the time which it will take to store all this value and to return back or get back all these values. Okay, so in this case it is not efficient calling a function if your functions are very small. So one solution in this case is using macros. In C, we have seen use of macros using hash define. So that also you can use to eliminate the use of function call. But they have a major drawback that they are not really functions and they may cause the error checking is not possible during the compilation. That means you have to take lot much care about the brackets and all that while using this macros, and that is sometime may lead to the wrong answer. So the another solution for that in C++ is the inline function. Okay, so the function which are very small, so the time which is required in storing the return address and all the registers on the stack and taking it back can be avoided by declaring that function as inline function. Okay, so an inline function is a function that is expanded inline when it is invoked. That means it will not do all this storing the return address and all that on stack, but it will be expanded when the function is invoked, at the place when the function is invoked. So that is, the compiler replaces the function call with the corresponding function code. It is something similar to macro. So it will not do a actual function call, but it will replace that function call with the actual statements of your function. So it is very easy to make a function inline in C++. So what we need to do is only use this keyword inline before we use that function. Okay, so just we'll see one example. So one more rule you have to follow is all inline functions must be defined before they are called. So before the function call is made, these inline functions has to be defined. Okay, so usually the functions are made inline when they are small enough and they are defined within one or two lines. So specifically it is used when your functions are small enough. Okay, because they are going to take less amount of time for execution than the time which is required to store all that things on the stack, that is return address, registers and all, and again taking it back. So in that case you can use it the inline. So let us take the example of this function. So this function is having only one statement, return a into a into a. So this function is small enough and it is executed using in only one statement. So in this case we can make this function inline. So how to make this function inline? Just use the keyword inline before the return type of your function. Okay, so this will make the function inline. So when you make the function inline, it will send a request to the compiler. Okay, so remember, it is a request to the compiler, it is not a command. So compiler not always treat all the functions and expand them inline, but we are just sending a request to the compiler, treat this function as inline. So compiler will take a decision based on few points that we'll discuss here, whether to accept this request or not. So it is not always mandatory that function will get expanded if we are declaring it as inline, but we are sending the request. The compiler may ignore this request if the function definition is too large. Okay, suppose by mistake for a large function I have defined the inline keyword, so compiler may decline this request. Okay, or if function is too complicated to compile, then also the request can be declined by the compiler. Some of the situation can be if the function returning values are inside the loops, or some switch cases or some go-to statements are there in your function which you have declared as inline. So compiler may decline the request. Next, function does not have a returning value. If return statements are not there in the function, that functions also compiler can decline and not expand them inline. If function contains static variables, in that case also request can be declined. And if inline functions are recursive, that means if they are calling itself, then compiler can decline the request of expanding the function. Okay. So inline expansion makes a program run faster because the overheads of function call and return is eliminated. As we have seen, when it is expanded inline, there is no need of storing the return address or the registers on the stack, and no need to take it back while returning from the function. So that overhead can be eliminated. But what will be the other side? It will increase the memory requirement. Okay, it will make the program to take more memory because the statement that define inline function are reproduced at each point where the function is called. So whenever the function is called, it will replace that function call with the code of that function. That means your memory requirement is going to increase. So that trade-off is there. Okay, so we know about time space trade-off. So same is applicable here. So if we are saving the time requirement by making it inline, it is going to in turn increase the memory size of my code. Thank you.